in which dimension we have to start our integration will be very important. So let's have this example firstly. Example number 2 from the reference book. Evaluate the double integrals. Now you understand what is double R means, dA. So R is a domain, is 2D domain defined by these two intervals, 0, 0, 2, and 0, 2, and 1, 2. So the function here is not separable. Will start anyway. If you start, if it is not separable, then you start dy dx, and we can do similar thing as we have done before in solution number I, or solution number 1, sorry, is we'll integrate with respect to y, means we'll treat x here as constant, then we'll just multiply with y. And the integration of 3y square is y, just y cube, because y cube divided by 3, 3 cancel 3. And the boundaries is from 1 to 2, then we'll till 2. So we'll substitute y 2 minus 1 and calculate, do the calculation, we'll get x minus 7, function of x only. Then we'll do the second integration to get negative 12, and we can do same thing here. You can read this example, you can complete. It's nothing is difficult. The one here, what I just tell you about, we have this non-separable function, and we have the two variables x and y, but actually the selection of with which variable we may start is an issue here. So our function is y times sine xy, and you can see in the angle sine has xy, x times y. All right, then if we just start to think to integrate with dx firstly, we'll think temporarily about the y variable as constant. And when we say y sine xy, if we treat this part as, or the internal integral as a function of x only, then we'll think about this y and this y as constant, which means our function will be a simple sine constant time x, which we can integrate from the simple rules. So we have also the derivative of xy with respect to x is y again. Derivative of xy with respect to x, considering y as constant, is y. And for example, if you have 3x, then the derivative of 3x is 3. If you have 5x, then the derivative of 5x is 5. Here also, considering y is constant, the derivative of xy is y, or yx is y. All right? So now, because we have this derivative, this function is ready, or the integration is from basic rules of sine. The integration of sine is negative cosine. Of course, y will disappear because we divide by y, the derivative. Y divided by y will cancel each other. So the integration, the internal integration, will be just a simple one function, cosine x, y. Now we'll substitute in x, becomes x cosine 2y minus cosine y, substituting x here. Then x disappears, and we have negative sign, negative, negative, positive. You know this story. So to be cosine 2y cosine y, the integration of cosine 2y is sine 2y divided by 2, and the integration of cosine y is just sine y and substitute here with the boundary from the interval. Sine 2 pi is 0, and sine pi also again 0, so the function is 0. All right, and this is a good selection here. And based on Fubini's theorem, we can do the opposite. And we can start, if you can see the pointer, I'm pointing to the second solution here. If we start with or try to do the integration with respect to y firstly, it will be done, no problem, it will be correct, and we must get same results. However, it will be too long and too complicated. It's too long. It needs a lot of steps. Why? Because here we'll treat the function, because we start integration with respect to x. We'll treat the function. We'll treat x as constant and y as variable. So x is constant here, like 2, 3, 4. We don't worry about this x. But here we have y sine something y. Y something y. It's multiplication of two functions which need to be evaluated using integration by parts. So we'll select u equal y and sine xy as dv. Then we integration by parts. Then we will differentiate this part and integrate this part and substitute in the rule, which is integration of u dv equal uv minus integration of u, and so on. Then in the second, this for the first integral with dx. The second integration, the entire one also needs similar story, such that we will select, we'll have two multiplication functions. Again, for second time, we'll need to have integration by parts. So we got finally the result, but it will be very complicated. I didn't present here in the slide, but that's what I mean. If you find, when you just check your function firstly, if you integrate with dx, then you have x appears in one time, then it will be a function, just a single function, sine x or sine x time constant, no problem. But if you try to integrate it with respect to y, you will have a complicated one. So based on Fubini theorem, select the easier one, please, and it will be shorter and you'll have same results. All right?